Hi, my name is Rhodes, and this is Physics Lab 1. Getting into some of the contents, we're going to have an intro, experimental observations, predicted observations, discussion, and a conclusion. For the intro, the purpose of this experiment is to compare a video of an object's motion to a computational model of its motion, and it's going to be moving at constant velocity. The fundamental physics principle at work in this experiment is Newton's second law, otherwise known as the principle of momentum. For a little preview of our results, an object exhibiting constant velocity is going to have zero net force acting on it, therefore initial velocity is going to be equal to final velocity, and nothing from the surroundings will influence movement. Newton's second law is known as the momentum principle, stating that a force is equal to the change in momentum over the change in time, as we can see on the right. On the left, we can also see another way to interpret Newton's second law as mass times acceleration. The procedure for this experiment will be recording an object at constant velocity using Tracker to map its movement. We're going to code the computational model in GlowScript from the data from Tracker. Then we're going to compare the motion of the observed video and the computational model. Here we have a little screenshot of the video we uploaded to Tracker, and from Tracker we got some data. We got time as it moves along in the video and how the position of the truck changes in regards to time. We then created a graph based on this data. We can see a relatively straight line indicating somewhat of constant velocity here. From our observations, we deduced that the system, under observations of the toy truck, the surroundings are not affecting the system. We start at t equals 0, and we end at t equals 1.201 seconds. The initial position is the origin, 0, 0, 0, and the initial velocity, 0.906, is calculated using the initial velocity formula, delta x over delta t. Getting into the coding that we did for the computational model, we took all that data, put it into this code. We used a while loop at t less than 1.201 seconds. We have no net force, and velocity and position update formulas were included, and this model gave us some data. From the data, we have a position versus time graph. As you can see, because there's no net force, it is a exactly straight line moving to the right with a positive slope in line with how the truck actually moved in the video. Comparing both of these graphs. So here we have the blue line, which is the experimental model, and the red line, which is the computational model. We can see that these lines are pretty similar here, meaning that the model matched the experiment pretty closely. The slopes of both the predicted and observed are positive due to the fact that the truck is moving from left to right. During this experiment, we had a few potential sources of error. So first of all, the experimental model might have experienced friction, considering this is a non-perfect example and the surroundings did play a small role in the motion of the system. In an ideal world, we wouldn't have any friction, right? The car would be moving across the floor and the floor would have no impact on the data that we received. We could see this impact in the slight curvature of the line from the experimental model. Additionally, Tracker could have also miscalculated distance, which would have impacted the velocity found. When you're using Tracker, you have to plot data points as a user. So this could produce some difference in data where it's not exact, right? It's not pinpoint. Getting to some what ifs. So my experimental object moved from left to right. However, if the axes were opposite, meaning right to left, the difference would have been opposite as well. So the slope would have been negative to show the object moving in the negative x direction instead of the positive x direction. What does this all mean? Essentially, it's going to be impossible to say the number of pushes and pulls with the current information that we were allowed to gather, right? The net force is 0, so all pushes and pulls are just going to cancel out, and they're not going to have any overall net force. Constant velocity means that there is no acceleration, friction forces, or outside force that could influence the motion of the object. We see this perfectly in the computational model. Again, in the actual experimental model, we don't see that straight line, meaning the floor might have caused the truck to, decelerate, and it might have caused friction. In conclusion, Newton's second law is seen in the observed motion of the truck and its constant velocity, which means that direction and speed did not change. There's no acceleration, so force equals 0 because of F equals ma. And Newton's second law says that constant velocity requires no net force to be acting on the object. Thank you.